We're almost there. Yay! We are finishing Chemistry 1132. We're going to talk about pages 21 through 30, which is going to take us to the end of the pace. And in fact, I want to take you to the very last page for just a second. See the pink box here? Congratulations. It has been a long, hard battle. You have toiled through many difficulties, yet you have run the race with patience. You've pressed on to the prize. You've finished chemistry. I don't think that's what Paul meant when he wrote it, but good application. You have finished this course. And it's been a tough one. We've tried to help you through it, and hopefully you've been successful on your tests. And you're almost on this pace. Like I mentioned at the beginning, is not as hard as some of the earlier paces with all the math, but there are some mind-stretching concepts that this pace covers. And this pace in particular is about nuclear chemistry. So let's talk about that in just a second. With the last paragraph of that pink box says, finishing chemistry does not qualify you for a job as a chemist, but it is a start. Finishing this course does demonstrate you have learned to trust God. Since you endured to the end, you are now qualified to face any challenge in life. And with God's help, conquer that challenge. You know, that actually is a good life lesson. You pushed through something hard. Partway through this course, I bet some of you were tempted to quit. I bet you talked to your parents, your supervisor, and said, I can't do this. This is too hard. I need to quit. Okay? But you didn't. You pushed through, and now you're to this point. You are so close to being done. And that actually is a good life lesson, that with God's help, and maybe you had the help of some tutors and some other videos, you used some resources, and you got through it. Good life lesson. There's going to be struggles you're going to have ahead. And God can help you, and others can be there to assist you and encourage you, and you can pull through those challenging times. All right, let's talk about nuclear chemistry. There's three types of particles. You've heard of radioactivity, right? Radioactivity would be an element that is giving off invisible particles, and those invisible particles are actually dangerous. Maybe you've been to the dentist and gotten x-rays on your teeth. And especially when some of my kids had braces, they would get these x-rays and they'd put something right up to their mouth, and then they would go in the other room and flip a switch and then turn it off. Maybe you've had that done, right? And what's happening is it's sending radiation through your mouth, through your jaw, to see if there's teeth down inside your jaw coming up and what all the structure is. But that radiation, if somebody is exposed to too much of it, it can cause cancer. It can cause other problems. So that's why the workers keep ducking around the side of the wall. And that's why they maybe put a heavy lead blanket over top of you, because that deflects as much of the radiation as possible. So, and they only direct it where they are looking with the camera. Anyways, that's an application of radioactivity. The other thing you've probably heard about is nuclear energy. Okay? And I'm not going to go off on a tangent about that, but that is one of the actually safest and most efficient ways to produce electricity. And the fewest people have ever died, especially in the United States, from producing electricity through that means. Okay? So maybe you want to study that out a little bit more. I think that is going to take over because of the emphasis on climate change and concern about other types of energy, burning fossil fuels, that type of a thing. Nuclear energy gives off a lot more energy that can be harnessed to produce electricity. So look for that. They call it Generation 4 nuclear energy. And if you have to write a paper, you might, if you're interested in science, look into that a little bit. All right, let's talk about the three main types of radiation that are given off. One is called the alpha particle, and that actually is the same as a helium atom, which means it has two protons, but it has a mass of 4, because each proton and each neutron have basically the same mass. So this is called an alpha particle. It's a helium atom. Beta is basically just an electron. So an electron has a -1 charge, and it has no mass, okay? It's so small, it's minimal, it really doesn't affect the mass of the equation. So for instance, uranium-238, this isotope of uranium, is radioactive. And over time, it will break apart, and it breaks down and releases, so I have this arrow showing this, releasing helium, a helium atom, into the air. And that has a mass of 4 and 2 protons. Well, when that leaves the nucleus of this particular uranium, look what happens. Take 92, subtract 2, and you get 90. Okay? And you take the mass of 238, subtract 4, and you get 234. So now we have thorium, because if you have 90 protons in the nucleus, that element is thorium. You can look at your periodic table. In fact, I just happen to have periodic table right here. Da, 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 da. And down here is element 90. Yep, right here, 90. So it goes from being uranium with 92 protons to thorium with 90. All right? Now that's stable for a while, but then it breaks apart. But when it breaks apart, it tends to release an electron, which also then affects the structure of the nucleus. And the net effect is you add, so you're subtracting a -1 from the nucleus, which in essence adds a proton. Okay, you have to read the PACE for a better explanation than I just gave you. But the mass stays the same, 234, but the atomic number increases by 1. Interesting. Okay, so that's called a beta particle. Then there's gamma radiation, and gamma radiation is the fastest and penetrates the most and can cause the most damage. It can cause cancer, and if they harness it, they can use it to actually try to kill cancer cells. Like there are people getting radiation therapy. Maybe your grandma or grandpa had cancer and they used radiation to try to cure the cancer, but they lost their hair in the process, okay? That's because the gamma radiation affects so many different parts of the body. The goal is to kill the bad cells. In the process, it also kills some of the good ones. But hopefully not so many that it takes their life away, but actually then they can recover and carry on for several more years. So I'm not going to go on any further than that. Your PACE is going to explain it more. They are going to have you do some of this. The math is not hard. Not even calling it math. And you don't have to do it on the self-test or the PACE test. Okay? So last thing, let's look at that checkup together. Go with me to page W and X. W and X. So there's a few terms there, and some of those you may feel like you already know. But I would look them over before you start this section so that you can kind of tune into, oh, transmutation. I think I have to know what transmutation is on the checkup, okay? Down here, number 14, the 4 types of nuclear reactions are radioactive decay, blank transformation. Okay, so study that a little bit. Figure out, okay, as I'm reading this PACE, I need to tune into 4 types. Question 24, I already gave you the answer to that. Radiation given off by radioactive nuclides can be classified as alpha particles, blank, and gamma rays. So I already kind of gave you an answer to one of your questions on the checkup. But look, that's all there is. 29 questions. Woohoo! And then you're up to the self-test. The PACE test is even easier than the self-test. You're going to do this. You're going to do this. There's terminology. There's words that are unfamiliar. Make study guides. Make note cards. Make a Quizlet if you need to. Find a way to memorize what you need to memorize. Blast through it, and you're done. Okay? Even if you get done and you say, wow, there's a lot there and I didn't understand it all, it's okay. It's okay. You're done. And you've been exposed to it. And you should come away, and here's the goal, I think, of the author of the PACE, and he mentions this a few times, and here's my goal for my students when they go through chemistry, is I want them to be totally blown away by how great our God is and what He has created in all these forms of chemistry. So hopefully that is an encouragement to you and will help you to be successful on this test.